All right, so today is Thursday, April 23rd. We're finishing up our discussion on sample means. And we've done several FRQ problems. We actually have 3 left. So we're going to begin with the 2004 question 6 problem. And so this is a longer problem, but it's actually not a difficult problem if you're not tricked. If you understand what they're asking, it's not bad at all. Obviously, if it confused you on what they're asking, it becomes pretty difficult. So, a pharmaceutical company has developed a new drug to reduce cholesterol. A regulatory agency will recommend the new drug for use if they're convinced, if there is convincing evidence that the mean reduction in cholesterol level after 1 month is more than 20 milligrams per deciliter. So that sounds important. So we need more than 20 milligrams per deciliter. All right, because a mean reduction of this magnitude would be greater than the mean reduction of the current most widely used drug. The pharmaceutical company collected data by giving the new drug to a random sample, oh, I like that phrase, of 50 people, I like that too, from the population of people with high cholesterol. The reduction in cholesterol level after 1 month of use was recorded for each individual in the sample, resulting in a sample mean reduction of 24 and a standard deviation of 15 respectively. All right, couple things before we actually get in, just give me a moment, I'll get to it. The regulatory agency decides to use an interval estimate for the population mean reduction in cholesterol level for the new drug, provide this 95% confidence level. All right, so they're telling us they want a 95% confidence level. They note, be sure to interpret this interval. Most of the time, they're not going to tell you to be sure and do it. They expect you to know to do that. So this is just because so when they say, hey, construct an interval, you always have to interpret it, whether they tell you to or not to. Another thing is, if you actually look at the scoring guideline, the conditions are going to be different than or they have fewer conditions than what we use. That is because time has progressed. This is a 2004 test, which basically means, it's about 16 years old, and they now require more conditions. So we have to address more conditions. So the conditions I'm giving you are not extra. They are the ones that you're really expected to use. Now, whenever they give me a hypothesis test or a confidence interval, if they tell me to do a confidence interval, I go ahead and I usually write what my null and alternative is. Not a requirement, but I do find that it somewhat helps. I'm going to see if I can do something real quickly. Hope it doesn't mess things up too much. Go to a new share real quickly. Or maybe it's not going to be quickly, but here we go. Awesome. So they told me they want a 95% confidence interval, and one of the reasons I drew this on here is because it reminds me that this is 0.95 in the center, and ultimately confidence intervals are two-tailed test. All right, so ultimately a confidence interval is a two-tailed test. So that was my main purpose for showing that. So once I've done that, and by the way, like I said, this is optional, but it tends to help me out in keeping things straight, and it only takes 5 seconds. So mu, the true population mean reduction in cholesterol level for the new drug. Conditions, random sample of 50 people, and it was given. All right. N is less than 10% of the population. So we need to check that. And we have a sample size 50 divided by 0.1 is 500. And it's reasonable to assume that there are more than 500 people with high cholesterol for which this drug might be, we could apply this drug to. The next thing is the test for normality. Well, fortunately, we have a sample size that's greater than 30. So the distribution of means is approximately normal by central limit theorem. So it's really important to say approximately normal by central limit theorem, but I also like to include distribution of means. Questionable whether this part is required, probably isn't. This part definitely is. All right, so then I go ahead and I record my formula. My formula is x bar plus or minus t star, s divided by the square root of n, and my degrees of freedom are 49. So I need to calculate t star because everything else was given to me. So second vars, inverse t, parenthesis, 1 minus 0.95, close parenthesis, divided by 2. Degrees of freedom is 50 minus 1, or 49. And I get a t-star of about 2.00096, or 2.0096. Now, obviously mine is negative. Always make your t-star positive. It just makes life easier. I mean, it's not wrong if you keep it negative. It's more difficult. All right. So I plugged into the formula, and I have 24 plus or minus 2,096. They told me the standard deviation of the sample is 15, and we know that my sample size is 50, and this was the sample mean reduction. So they gave me that. So at that point, I'm going to go stat test, and I'm going to scroll down until I find t interval, which is 8 on my calculator, and I plug in 24, my standard deviation of 15, my sample is size 50, and my confidence level of 0.95. And there's my interval, 19.737, 0.28, 28.263. So I record that. Great. Still haven't done my most important part. What is it? Well, we are 95% confident that the true population mean reduction in cholesterol level for the new drug lies within this interval. Fantastic. All right. The next thing, they didn't ask for this, but had they asked me what the 95% level meant, so if they asked me what my confidence level meant, or the 95% level meant, then I'd have to go in and answer this question, which is in repeated sampling, we expect that our method would capture the true population mean reduction in cholesterol level for the new drug 95% of the time. This was not required for this problem. All right. If you included it, nothing, there is no harm, no foul. This part right here absolutely was required. That is required for any time you do a confidence level. So that's part A of this problem. Now, for some questions, it's like, gosh, that would be just about it. But for this one, because it's a question 6 or investigative task and takes a little more time, we have multiple parts. So we move on to part B. Because 95% confidence interval includes 20, the regulatory agency is not convinced that the new drug is better than the current bestseller. The pharmaceutical tested the following hypothesis. Well, hold on just a second. This right here is different because now we have a mean at 20 and we have a one-tail upper tail test, so the area here is 0.05. Let's contrast that to the confidence interval. The confidence interval, both of them have an alpha equal to 0.05, alpha being the area in the tails. But this one has a 0.025 in each one of the tails. So consequently, if this were centered at 20, this distance from here to here is farther than this distance. So this one is actually closer. This has a larger upper tail rejection. So this has a larger upper tail rejection than does this one. Okay? All right, so the test resulted in a t-value of 1.89 and a p-value of 0.033. Because the p-value was less than 0.05, the company believes that there is convincing evidence that the mean reduction in cholesterol level for the new drug is more than 20. Now, if this were me and I was trying to come up with a long question for the AP exam, which is what they're going to do this year, is they're going to try to come up with a long question, I would say, hey, they got a test statistic of 1.89. What's the p-value and what would the company's decision be? Well, you would go, okay, if they'd just given you the 1.89, you should have been able to go second VARS, TCDF, lower bound 1.89, because we're dealing with an upper tail test, 99999, and degrees of freedom is again 50 minus 1, or 49. And so there we go, 0.033. Now I know that there's a little bit of rounding differences between the two, but this was done correctly. All right, so that calculates the p-value, and they say, well, would I reject? And I'm going to go, well, yeah, 0.033 is less than 0.05, so we reject. There's sufficient evidence to say that the true mean reduction in cholesterol for the new drug is greater than 20. But that's not what they were interested in here. They said, hey, explain why the confidence interval and the hypothesis test led to different conclusions. Well, we kind of already talked about that. Basically, we said they have a rejection region of 0.025, the regulatory agency with their confidence interval, and whereas when we ran the hypothesis test, we ended up with a rejection region of 0.05. So in this part, the test here, so here comes my answer, and it's long. The confidence interval in part A was a two-tailed test with an alpha level of 0.05. Because it was a two-tailed test, the rejection region in any one tail was 0.025. In contrast, the hypothesis test that the company ran was a one-tail upper tail with the entire 0.05 alpha level all in the upper tail. Because the company had a larger rejection region of 0.05 than that of the regulatory agency's 0.025, the company was able to reject the null. As a result of the different sized rejection regions, the company and regulatory agency had different conclusions, even though the alpha levels were equivalent. Then, for the test to have been equivalent, the regulatory agency would have needed to use a 90% confidence level. You're like, okay, Mr. Spencer, how did you come up with that? Well, I came up with that based on this. This has a 0.05 all in the upper tail. Well, to do that, confidence intervals, all are based on a not equal basis, but I still have to have 0.05 in the upper tail. Well, if I have 0.05 in the upper tail, I also have 0.05 in the lower tail, so I only have 0.90 in the center, which would make the 90% confidence interval. On the other hand, if the company had used a significance level of 0.025, it would have been equivalent to the 95% confidence interval that the regulatory agency ran. That part is extra material. I could have, as long as I chose one of those methods, either compared to the 90% interval or compared to the 2.5% significance, I'd be fine. All right. Had that been the case, the p-value of 0.033 would have been larger than the 0.025 alpha level, and the company would not have been able to reject. Right, this should have been a 0.025 right here. So if they had done a one-tail, if the company had done a one-tail, so in summary, if the company had done a one-tail upper tail test with a 0.025, they would have had the same rejection region as the two-tail 0.05 or 95% interval, and both would have failed to reject. If the regulatory agency had used a 90% confidence interval, they would also have had the same rejection region in the upper tail. So we're only looking in the upper tail. So that's actually really complex, but I don't think it would show up. However, you do need to know that basically going from one tail to two tails doubles your p-value. All right, so with that said, do you all have questions on part B? Because that was pretty challenging in my opinion. Look at all the geniuses I have online this morning. All right, so part C. Part C is designed to scare you. It really is, because it's not that bad at all, but they designed it to scare you. So the company would like to determine a value L. And immediately, if I'm you and I'm taking the middle of a test and I go, L, Mr. Spencer never taught me about L. You know, it's almost like, what the L is that? So here we go. The company would like to determine a value L that would allow them to make the following statement. We are 95% confident the true mean reduction in cholesterol level is greater than L. A statement of this form is called a one-sided confidence interval. And you're like, okay, I know Mr. Spencer didn't teach me this. And you're right, I didn't. That's why fortunately, there's no questions, there's no investigative task. This is considered an investigative task where they've made up something that they know you haven't been taught and want to see how smart you are and see whether you can figure it out. And they go, the value of L can be used finding the following formula. So they gave you this formula. I should have left it in black because they gave you that. All right, this has been this has the same form as the lower end point of the confidence interval in part A, but requires a different critical T value. What should be used for T star? Well, basically they're saying, hey, we're going to have, instead of having a two-tailed confidence interval, we're going to have a one-tailed confidence interval. And this is the company speaking. So if they were doing a one-tailed confidence interval, how much area do they want in that tail? Well, they're telling you, well, we already know that they want 0.05 because they want to be able to make a 95% statement, so this needs to be 0.05. So what do I do? Well, we go back and we go second vars, inverse T, the area is going to be parenthesis 1 minus 0.95 divided by 2, degrees of freedom is 49. And when we do that, excuse me, I did that wrong. I don't divide by 2 this time. I'm sorry. I don't want 0.025, I just want 0.05. So second vars, inverse T, 0.05, degrees of freedom 49, and I end up getting a T star of about 1.677. So that's my T star value. So T star is 1.677. Continuing on, recall that the sample mean reduction in cholesterol level and standard deviation are 24 milligrams and 50 milligrams respectively. Compute the value of L. So L equals X bar minus T S divided by square root of N. They gave me that. That was something they gave me. And I just plugged in 24 minus the T star value that we just calculated. 15 was a standard deviation sample size of 50. And when I do that, I find out that L is 20.44. So here's what this is telling me. They're telling me that we have an X bar at 24, and then we have a lower level of 20.44. This area is 0.05. So what we're saying is we believe that the new drug has at least a 20.44 reduction in cholesterol level. So our statement, we are 95% confident the mean reduction cholesterol level is greater than 20.44. Why? Because this area is 0.95. All right, lastly, part D. If the regulatory agency had used the one-sided confidence interval in part C, so if they had used this as opposed to this, rather than an interval in part A, would it have reached a different conclusion? So if we'd used part C versus part A, would we have gotten a different conclusion? Well, part A, we said, hey, you know what? 20 lies within the interval. Because 20 lies within the interval, we can't say that there's a difference. Here, we're above 20. Because we are above 20, we say that there is a difference. So the regulatory agency would have reached a different conclusion. So that right there tells them, hey, they made the right decision had they used the one-sided from Part C. Part C created a lower bound of possible cholesterol level of 20.44 because 20.4 was above the value of 20. The regulatory agency would be 95% confident the mean was at least 20.44, which is greater than the current 20. So basically, at that point, they're saying, hey, you know what? If we'd done a one-sided instead of a two-sided, we could still make a 95% confidence claim, and we have enough evidence to indicate that the new drug was better. So hold on for just a moment. All right, our next question is question 2007, question 1. The Department of Agriculture at a university was interested in determining whether a preservative was effective in reducing discoloration in frozen strawberries. A sample of 50 ripe strawberries was prepared for freezing. Then the sample was randomly divided into 2 groups of 25 strawberries each. Each strawberry was placed into a small plastic bag. The 25 bags in the control group were sealed. The preservative was added to the 25 bags containing strawberries. So we have 50 strawberries, 25 are control group, and 25 have a preservative. They're both frozen, and we want to see, and then they're frozen for 6 months, and we want to see which one has the greatest discoloration, whether or not the control group had or whether the preservative helped get rid of discoloration. And we're just having someone rate it on a scale from 1 to 10. The low score indicating little discoloration. So low score is little discoloration. And then I have the dot plot. So let's just look at the dot plot for just a moment. So this one right here got the preservative, and this one did not. This one is reasonably symmetric and looks to be centered about 5. I'm not sure. Maybe I don't know what shape I'd call that, but I'm guessing the center is somewhere between 6 and 7 without doing any calculations. Now, I could have calculated this out. I know that there's 25 in each, so my median for this one would have been at 13 and at 13, so because there's 25. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so my median's at 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So my median's right here at 5. All right, so this one appears to have a little bit less discoloration than the control group. So it appears the preservative helped a little bit. Maybe not a lot, but it definitely helps some, or at least that's what it appears. Okay, so question A. First question. That's a weird question. The standard deviation of the ratings for the control group is 2.141. Explain how this value summarizes the variability in the control group. Well, standard deviation is a measure of variation. And please remember, from a formula basis, it's something like this. The summation of x minus x bar squared over n minus 1. Or if you're working with means, it'd be something along the lines of x minus mu squared over n. Now, you don't have to memorize the formula. But we need to know that, hey, basically, this is an average because I'm dividing by the sample size, and this is how far an individual value is from the mean. This is how far an individual value is from the mean, and again, it's about like an average. So the standard deviation provides an average, because we're dividing by the sample size, that we would expect a value to be from the mean. So, gosh, that is what it is. It's the average, because we divided by sample size, how far a value is from the mean. That's what it is. That's definitionally correct. Then I need to put in context. So context. On average, you would expect an individual strawberry's discoloration to be 2.41 points from the mean level of discoloration in the control group. So in the control group, we'd expect the discoloration to be 2.41 points from the mean on average. Okay? So that's the definition of standard deviation. That's probably something that you should know, and probably something I should strengthen in the course. All right. So I went and copied the dot plots over, and it says, based on the dot plots, comment on the effectiveness of the preservative in lowering the amount of discoloration of strawberries. No calculations are necessary. All right. So I just immediately said, you know what? This center is lower than this one. So consequently, there's less discoloration, or there appears to be less discoloration when you apply it. And I just used the median that we calculated before, or that we counted out before. So this median we said was at 5. We said this median was at 7. So, short answer. It appears that the preservative did lower the amount of discoloration. We answered the question, as evidenced by the fact, and we have to give a reason why. We need to give a justification. Even though they didn't say it, you have to give the justification. It appears the preservative did lower the amount of discoloration, as evidenced by the fact that the treatment group's median discoloration level was 5, while the controls group's median is 7. Now, when I went through and looked at what College Board counted for scores, I was a little disturbed by College Board. I was like, you guys are double dipping. And here's what I mean. They specifically said no calculations are necessary. But then they went and calculated IQR, they calculated mean, they calculated median, etc. Personally, I would have just done the median. And if you had just done the median like we did here, you would have received full credit. But I was like, no calculations are necessary. That should not have been part of their answers. They should have accepted it if someone did it, but they actually included as in their write-up. Kind of not happy with them for that. Okay, so, but just calculating the median would have gotten you full credit, or counting out the median. So researchers at the university decided to calculate a 95% confidence interval for the difference in mean discoloration rating between strawberries that were not treated with preservative and those that were treated with preservative. The confidence interval they obtained was 0.16 to 2.72. So the discoloration level difference lies within that interval. Assume that the conditions necessary for the confidence interval are met. It's a good thing to tell us. They're saying that, hey, we had a right to run the test. Everything was done right. So based on the confidence interval, comment on whether there would be a difference in the population mean discoloration rating for the treated and untreated strawberries. Well, if I just look at the interval, what I notice is it doesn't contain 0. If it doesn't contain 0, then there is a difference. All right? So based on the interval, we could say with 95% confident that there exists a difference between the mean discoloration level of treated and untreated berries because 0 is not included in the measure. So there you go. There is a difference because 0 is not included. And that would have gotten you full credit. That simple. And you didn't have to write the measure of no difference. You could have just said an untreated 0 because 0 is not contained in the interval. So this statement minus the measure of no difference would have sufficed for that problem. So all in all, a fairly straightforward problem. However, I had a couple of issues with them, and I'll talk about both. One of them I already talked about, this one was, they actually ran the calculations, but they weren't necessary, which was good. Here, this one, they were very, very picky on. And you had to be really, really careful to make sure that you included, obviously, you should always include context, but you need to show definition. And if they just said average discoloration from the mean, they didn't accept that. As a matter of fact, they didn't even give them partial, which was amazing to me. And the only thing I did different was I defined it first. And the defining it first took it from no credit to full credit. So I highly recommend defining things first, then putting them in context. Had you defined it only, they would have given you partial. Anyway, I thought they were a little bit crazy on their grading, but that just is what it is. So always do the best you can and try to give a complete response within a time allotted. So at this point, I'm going to pause the recording. So this should have said 2008 Form B, question 3. So that's what we're going to work. And a car manufacturer is interested in conducting a study to estimate the mean stopping distance for a new type of brakes when using a car that is traveling at 60 miles per hour. The new brakes will be installed on cars of the same model, and the stopping distance will be observed. The cost of each observation is $100. A budget of $12,000 is available to conduct a study, and the goal is to carry out the most economical way possible. Preliminary studies indicate sigma equals 12 feet for stopping distances. All right. The question, are sufficient funds available to estimate the mean stopping distance to within 2 feet of the true mean stopping distance with a 95% confidence? Explain your answer. Well, I start off and I write down the formula for the confidence interval. I know that this is a Z because I'm giving the standard deviation of the population. Because I'm giving the standard deviation of the population, I know I'm working with a Z instead of a T. So X bar plus or minus Z star sigma divided by square root of N. Well, I really don't care about doing a confidence interval. I only care about the margin of error. And margin of error is this part. So this right here gives me the margin of error, and they're telling me that needs to be within 2. Well, a second VAR's inverse norm is 1.96, and then I just plugged in and I solved by algebra, and I showed all these fancy steps, and at the very end, I ended up getting 138.29. Please remember, so I needed a sample size of 138.29. N has to be a counting number, so that means I have to round it. And because, so in this case, I would have to round it up. If I rounded it down, I would have received partial credit. Think of this. If you have to make a 73.1 on the final in order to make an A in the class, then will 73 be adequate? And the answer is no. So the only way you can get there is if you make it 74. So you always round up in this situation. We rounded up to the next whole number is 139. This is great. 139. Well, 139 times $100 is $13,900. Oops. They only have $12,000. So they do not have enough money. So the company does not have enough money to conduct a study within 2 feet. They need $13,900 and they only have 12. You're out of luck. All right. Part B. A regulatory agency requires 95% level of confidence for an estimate of mean stopping distance that is within 2 feet. So you must have 95% confidence. You must be within 2 feet. The car manufacturer cannot exceed the budget of $12,000 for the study. Discuss the consequences of these constraints. I'm like, how is that different than part A? So I try to put myself in the student's shoes. It's like, because to me, they're essentially the same question. And we'll talk about this in just a moment, because I'd like to hear your how you feel about this. So I sit there, hey, I already answered this in part A, but they're obviously wanting something different. I don't even know what they want different. And since I don't know, I was like, well, how can I address the consequences? Given the constraints about the problem, the company is not able to meet the requirement of the regulatory agency. Well, duh, we said that before. They only have enough money to run 120 tests, and they need to run 139 within 2 feet to satisfy the 95% interval requirements. Okay, well, that was duh. That's pretty much what we said in part A. Slightly different, but pretty much the same. Turns out if I would have had that for part B, they probably would have been happy with me and I would have been okay, but I wasn't sure. Because I wasn't sure, I went on. I was like, well, let's run it based on their 120. Well, if I do that, I end up getting 2.147 feet. So my margin of error is 2.147 feet. I needed it to be 2 feet. That's not the right size, but at least I know that that's what they can do. So then I make that statement. The company only has enough money to be within 2.147 feet. So maybe you can bribe one of the regulators to round the 2.147 feet down to 2 feet. I don't know. Because once again, I'm desperate. Turns out this also probably would have been an acceptable response. So this was an acceptable response. This was an acceptable response. And then I went on a little farther and I said, hey, I resolved it. And I came up with a Z-star of 1.8257. When I did that, and I would have used this drawing, and I've been solving this, I find that this area right here is a little over 0.93. So the company can achieve the 2 feet distance if they change to a 93% confidence level, or if they just increase the sample size to 139, or if they find a way to decrease the variation in braking distance. So basically, I was like, you know what? I don't know what the answer is, but there are a few things that could happen. Change the distance to 2.147 feet. They could change the confidence level to 93%, or they can increase the sample size to 139. They say they don't have money to, but that's where things stand. So my own personal questions, any one of these three would have satisfied part B, but I had no idea. I didn't know what they're. So I go to then I have my own comments just because I was a little upset about this. So who needs brakes anyway? Of course, you can't stop. You're going to fail to maintain the 6 feet social distancing requirement. But on the plus side, you never know who you might bump into. So that right there concludes hypothesis testing and confidence intervals for sample means, 1 and 2 sample means. And beginning Monday, we will do proportions.